In this video, we'll take a look at z-scores and the normal distribution. On your screen, you can see towards the bottom it says z-value, and you can think of this as a z-value or a z-score. And notice that it's labeled with a 0 at the center there. So that's a z-value of 0. And in a normal distribution, the center is always 0 when it's in z-score form, and it's also equal to the mean as well as the median and the mode. So the mean, median, and mode are all equal to each other, and they happen to be a z of 0 in a normal distribution. Next, notice that to the right, the values they increase, where we have a z of 1, and then of 2, and then 3. And then to the left, we have a z of -1, -2, and -3. Now, it's helpful to know that in a z-score distribution, each z-score indicates the number of standard deviation units a value is from the mean. So, for example, this z of 1 here, if there was a value right here at a z of 1, it means that that value is 1 standard deviation above the mean. For a z of 2, it's 2 standard deviations above the mean. And for a z of -2, for example, that's 2 standard deviations below the mean since it's negative. So anytime you hear a z-score, like a z-score of -2, that indicates the number of standard deviations a value is from the mean. And since it's negative, once again, it's below. Now, we can look at this curve and isolate some various areas and find the proportions or percentage of values under the curve in those areas. So let's go ahead and take a look at that. So from a mean of 0 to 1, the proportion or area under the curve there is 0.3413. And you may recall that a normal distribution is a symmetrical distribution. So in other words, if we slice the distribution exactly in half, one side is a mirror image of the other. So if from 0 to 1 our proportion is 0.3413, then it should make sense that from 0 to -1 the proportion is also 0.3413. And that's always the case because the distribution is symmetrical. Now, often what you'll see is people will add together these two values to express the proportion of obtaining a value between -1 and +1. And if we do that, we can see that it's equal to 0.6826. In other words, 68.26% of the values in this entire distribution fall within a z of -1 to +1. So 68% of the values are in this area here. Now next we can look from a z from 1 to 2 and see what proportion of values fall in this area. And it is in fact 0.1359, or 13.59% of the values fall between a z of 1 and a z of 2. Or put another way, from 1 to 2 standard deviations above the mean. And recall that the normal distribution once again is symmetrical. So if this area from 1 to 2 is 13.59%, then you should be able to figure out that this would be the exact same, or 13.59% as well. Now, just like we added these two values here together, what often is done is one adds all the values from -2 to +2 as well. And if we did that, that would mean we'd add these 4 values together. And that would give us a proportion of 0.9544. Or, put another way, 95.44% of the values under this curve all fall from a z of -2 to +2. Or they all fall within 2 standard deviations of the mean here. Now let's go ahead and take a look at 2 more values. From 2 to 3, the proportion is 0.0215. And then as you know, since it's symmetrical, the proportion would be the same from -2 to -3. So there's 2.15% of the values, they occur from 2 to 3 standard deviations above the mean, and the same 2.15% of the values occur from -2 to -3 standard deviations below the mean. And if we went ahead and added up all of these values, so that is all 6 of these values together, we should get 0.9974, which tells us that 99.74% of the values in a normal distribution all fall within 3 standard deviations of the mean. Or in other words, they fall from -3 to +3 of a z-score. Now, there are, if we do the math here, 0.0026, so 0.26% of the values fall above 3 and below -3. So just a small fraction of the values fall outside of 3 standard deviations of the mean. And you may have seen this before. Notice we have 68%, 95% within 2 standard deviations, and 99.7% within 3. And this is known as the 68, 95, 99.7 rule, which means once again that 68% of the values fall within 1 standard deviation of the mean, 95% of the values fall within 2 standard deviations of the mean, and 99.7% of the values fall within 3 standard deviations of the mean. So once again, this is referred to as the 68, 95, 99.7 rule. And it's important to note that it only applies to a normal distribution, or a bell-shaped or Gaussian curve. So if you have like a t distribution or an f distribution, for example, this rule would not apply to those distributions, just to the normal distribution. Okay, that's it. Thanks for watching.